So welcome everybody, thanks for joining. I'm glad we've got quite a few people here. I was worried that the title might scare people off. It shouldn't, because to be honest, I don't even really know what a GenZ is, to be perfectly fair with you. But I thought it was such a great title that I should do it. It does hint a little bit at some of the problems that are upcoming as I see them. It's going to be a very quick talk, like we've only got 30 minutes including question time, so there will be a lot of things that I'll kind of fly through and I'll try not to get too deep into things. Maybe first up, is there anyone here who's worked with mainframes? We got a couple. Anyone that's hacked a mainframe or penetration tested a mainframe? Ah, yeah, these guys. I think I know them. Okay, so let's get into it. First off, who am I? We had a little bit of a introduction before. I'm a senior consultant at Inviso. I'm not a mainframer. I won't claim to be. I've learned a lot about them in the last few years, probably more than the average penetration tester, but mostly I'm a hacker. I like to hack things apart. I like to hack things together, and that's where I'm coming from. I was a kid in the 80s. Why is this important? Well, back in the 80s, we sort of got this look for the future of what we were going to be dealing with. I got a Commodore 16 when I was very young, and we were promised like this future of where we could buy things online using our computers and they would come to our house, which is sort of coming, and we had cars that talked and all this sort of thing. So it was pretty good for me, like the breeding ground for technology for the future. And of course, the idea of hacking the mainframe was always toted around. You hacked algorithms and you hacked the mainframe, and that was like, whoo, you'd done it. I own my very own AS400, for anyone who knows what that is. For those who don't, it's not a mainframe. It's a little baby thing that's kind of old. And I thought that it would be a bit like having a mainframe because I couldn't get one of my own. Also, I'm building a Dalek. Anyone who knows what that means probably finds it pretty cool. Everyone else is like, who the hell is this guy? First off, let's do a shout out, because we're always standing on the shoulders of giants when we're talking about mainframes. In the technology itself, like these things have been around forever. Well, 60 odd years. And when it's talking about hacking, the guys that we're looking up to here is Phil Young and Chad Rickensrud, otherwise known as Soldier of Fortran and Big Indian Smalls. These guys are the ones that got me interested in mainframe hacking. In the actual hacking of it. Like, as I said, as a kid, you wanted to hack the mainframe. I didn't know what it was, but I wanted to hack it. So yeah, these guys wrote the only pen testing course for mainframes that is in existence. It was recently sold by them to Broadcom. Probably anyone that tried to download VMware lately from them is aware what that's probably done to the availability of what's going on. So let's take a step back in time, back to the 90s. Back in the 90s, a guy called Stuart Alsop made a very chilling prediction. The last mainframe will be unplugged on March 15, 1996. Oddly specific, I thought. But that's what he said, and probably a few people believed him. Given that I'm actually standing here, we probably can work out that he wasn't quite correct. And around 2002, he actually published a photo of himself eating his words. So we still have mainframes, in case anyone didn't know, and I assume you probably were aware of it, otherwise you might not be in this talk. But we have to bust some of the myths about them. One of the myths that we have to deal with is people think that they're outdated. They're like these technological dinosaurs. I mean, they are quite big, they are quite bulky, but they're not what we usually get in our minds when most people hear mainframe. Most people are thinking this. Who was thinking this? Yeah, we had some of those. Yeah. So what we do have here is a mainframe. This is kind of where it's all coming from. And what you actually see there, this block just behind the gentleman to the left, that's actually the main frame of the system where all the good stuff was happening. All this other stuff is data storage usually, and then he's sitting at a console that he was using to run it. It's not what they look like anymore. I'll introduce this guy here. This is what we're talking about now, the IBM Z16. It's a modern machine. It fits in like the space that you'd have a 19-inch rack in a data center. And you can like scope them out to have one machine that's like 4 of these. And so, yeah, they're like a big fridge. But they're beasts of computing. And you see here, they've introduced on-chip AI processing. So for all the AI fans, they're actually putting that on the chips so that they can do it faster. Why do they do that? Well, service user agreements to make sure that payments get processed quickly can actually be run through fraud detection. And the only way to get that speed that you need, I think, don't quote me, I think 6 milliseconds or something the process has to take for the transaction to be approved. So they put that on the chip. Quantum safe computing, they have pervasive encryption that you can have on these machines, encrypt all the stuff and do it with a quantum safe algorithm. Up to 40 terabytes of RAM. The processors can talk to each other at a speed of around 250 gigabits per second. They can actually address RAM or level the cache on other processors faster than some Intel machines can talk to their own onboard memory. So that's an idea of like the sort of power we're talking about. They can process up to like 19 billion business transactions per day. So, I mean, that's a lot of stuff. And the main reason why people would have a mainframe over anything else is this availability level of 7 nines, they call it. So 99.99999 availability, uptime. So not much downtime. Very, very little downtime, almost none. They also test them to withstand an earthquake of 8.0 on the Richter scale, which is quite a lot. I come from New Zealand. We know a bit about earthquakes. So we probably should have some mainframes. I don't even know how many we have there, but it's beside the point. Just some little statistics so we know how important these things are. We see there like 90% of all credit card transactions. 90% of all of them, and that's a lot of transactions. We have 77 out of the top 100 banks are using them. All of the top 10 insurers, apparently. 71% of the Fortune 500 are using them. And apparently 68% of the world's production IT workload. Not so sure on that one myself, but they determined it in some way. It's also interesting the way they do the workloads based on cost as well, because people think these are expensive machines. They are. They're very expensive. But the amount of work you can get out of them is huge. Also, market size, 2.5 billion last year, apparently, and a growth rate predicted of 6.4% until 2032. So the mainframe is by no means dead. As you see, it's doing important work. It's a very important piece of infrastructure that we're talking about here. Myth number 2, and this is the main one that we're interested in right now, impenetrable digital fortresses. It's very true that they are very secure. They have been developed over the last 60 years. There is still code from back in the day. So it's not a wonder that it's very stable. But of course, it is not impenetrable. Nothing is. We probably all know that, I think. At least all of the penetration testers know you can eventually get there somehow. And why aren't they immune to compromise? Well, it's quite a simple fact. The same reason anything isn't. And that's it's a computer. It's built by humans, configured by humans, used by humans, blah, blah, blah. Basically, layer 8 problem. And that's what the security is based on here. It's always down to how well is it configured, that kind of thing. Also, a lot of people think like we're hiding it back behind our perimeter. It's tucked way down away from everything else. Not entirely true. Quick showdown result. 161, and this is just based on looking for the TSO or the VTAM. So this is like the console that you're using to administer them usually. So yeah, we've got a few of them there, and as we can see, if we look down under ports, under 23, we've got 49. So that's plain text, most likely. Doesn't have to be, but most likely. There's still a lot of plain text around. Glad to see that the number of 992 is actually higher. But yeah, that's what we're dealing with there. And this is current. I did this a couple of weeks ago just to check. The other one is FTP. People say, FTP, what's so interesting about FTP? Well, you're going to see in a little moment that FTP on a mainframe is not quite FTP. It does do FTP, but there's some other stuff you can do with it, which is pretty neat. And if you abuse it, you can do some very neat stuff. Here as well, you can see port 2184 of 92. I can almost guarantee that those are most likely clear text. So if you can sniff the traffic, you can get credentials. Why haven't we heard about them getting hacked? Has anyone ever heard of mainframes getting hacked? Like big names? No. Well, there has been a couple of big ones. I'd say generally the reason why we don't hear about them is it's not the kind of thing IBM want to be sort of hanging up on the wall. Look, we got hacked. Our secure platform was hacked big time. And we did have it. This was a while ago, 2012. Logica and Nordea. That's a provider of government IT services in Sweden and a Norwegian bank. It's one of the only well-documented mainframe hacks that we have in the public domain. It was attributed to a guy called Anakata. Does anyone know who Anakata is? Or Gottfried Svartholm? He was one of the founders of Pirate Bay. And when he was in Cambodia, staying away from Sweden, he allegedly did these hacks. He was convicted of them in the end. He got initial access via some stolen credentials. He did some, I think it was the lawyer that was dealing with him from the government, and she had access to a government system, and that was sort of his initial foothold. From there, he managed to probably develop 2 0-days that he found. And he used them. Interestingly enough, he actually developed these exploits using an emulator called Hercules and an older version of ZOS. No doubt he refined them then on the systems that he was actually attacking. The interesting points that we have here is the concept of 0 days. These 2 0-days became CVEs. You don't often see CVEs related with mainframe products. I think fairly clear that it's not something, once again, that IBM wants to have a big deal made out of. The other thing being the use of the Hercules emulator. This is an interesting one. You can't do that legally. It's not allowed. But, of course, if you're a criminal and you want to, then it's not going to stop you. Which brings us to the challenges that we're facing at the moment as I see them. So we've basically got 3 broad areas that we're looking at. First one's the skill gap. Obviously, the people that are experienced in the mainframe area tend to be heading towards retirement. It's not often something that the Gen Zs are actually doing, although it's improving. I will say that. It's definitely improving. There is light at the end of the tunnel. There is but still a limited number of people getting into it. And the learning curve is steep. You can't use anything that you knew already about computers. It's not like, oh yeah, I used to use a Windows machine, now I can use a mainframe. No. With Unix or Linux experience, there are some things that are going to help you out, and that's something that we're going to see in a moment. Approachability. For a long time, the community was kind of toxic. A lot of forums. I got the impression if we fed them into an LLM, we could build a chatbot, but I got the feeling that the only answer we would get from it to every question was, have you read the manual? And should you really be touching this? You don't seem to know what you're doing. I'm not entirely sure that that's really overrated, or that's not an overstatement. There are some things you find where people ask genuinely honest questions. Once again, this is improving. I will say it is improving. There are a lot of people are getting more open. They're more willing to talk, but there's been a bit of a problem. The main one that I see as a problem is access to it. As I already mentioned, you can't use information you've already got. How are you going to get and try and play with this, particularly if you're going into bug bounties, or not bug bounties, there's no bug bounty for it, but if you're going into looking for exploits, looking for weaknesses, even just learning how to administer these systems, the only way that you really get access is if you work somewhere where they have access and they'll let you play around with their machine. The other one is you can get a developer license for one person from IBM, where you can run on an IBM emulator on your own machine, but the license costs you 7,000 euros, which puts it for one person, for 1 year, and that puts it a little bit out of the realm of the average hobbyist or the average hacker or penetration tester. There's a limited amount of training. There are some very good stuff. IBM puts out something called Z Explore, which is a fantastic training resource. And there's a company called Interskill, which works closely with IBM, and they have some good content as well. But it's not the sort of thing that we see like with things like Hack the Box or any of these online pen testing frameworks where you can actually go and try stuff out. Last one, oversight. A lot of what I've seen is that penetration testing of mainframes doesn't really happen. Generally, mainframes out of scope, don't touch it, please. Sometimes you might be allowed to touch one application, but often you hear like, well, no, we don't want you going any deeper on that. So you get one application, you look at it and you say, well, to be honest, that's not how I'm going to break into your mainframe. Good that they're testing it, but not always what's going on. So now we've got a bit of that out of the way. I think we should move into the actual hacking part. For those that are familiar with the movie Hackers, I'm going to hack the Gibson. So just let me change screens. Let's come back. Okay, sorry. As I have to stop this one. Okay. We've got it on there, but not on there. Okay. Sorry for everyone over here. You have to look over here. Unless our man here's got something to find out. Okay, so we're going to have a go at hacking a mainframe. For the mainframers here, I'm sorry. I'm going to do stuff that's like probably a bit out there. Like you'll say, I'm not really sure that would happen in real life. But some of these things do. So let's consider the situation. We're already inside someone's infrastructure and we're targeting the mainframe. Awesome, thank you. And we've got some credentials. Most people say, hang on, you've got credentials? It's not hard to find credentials. Ask a red teamer, you'll find credentials. The start of this actually comes from an assessment that we did where we found some credentials inside a code repository, and they were for an FTP user. So let's just have a look here what we've got. So we know the host is the Gibson, our user is Dade FTP, and his password is bsides24. When we're looking at it, we do an nmap of the Gibson. This won't take too long. There we go, we've got some ports open. The ones I care most about are 2122 and 992. We know that this guy is an FTP user because it's obvious, like his name's FTP, so we'll start with that one. If we start from there and we go FTP, and then we do Dade FTP at the Gibson, you see that the correction was working. Of course, I tried this out before. It's not the first time. Oh. You'd think it was the first time. That's more like it. Okay, so we've got Dade FTP, and we're in FTP, and it sounds like normal. We're FTP, we'll find some files. Do we find any files? No, he hasn't got much there. But we had a bit of a sniff around, and we found a couple of users that we were interested in. One was zcool. Have people here seen Hackers, by the way? And we look at zcool. Ooh, SSH. Let's have a look at that. We go in there and we see what we've got. Okay, so we've got an SSH key by the looks of things, but we're not allowed to see it. And authorized keys, sure, we could write our own one to there, but no, we can read them, but we can't write them. So that was kind of interesting, but let's come back to it. There's another one, ACD burn. And we have a look there. Okay, so we do have a little something there, also something that we can't get our hands on, but it's a common CA cert. Really? Okay, I've got to go very fast now. I knew this was going to take too long. Okay, so common CA cert is what we would use for our protected connection over the 992 for the terminal. But what we want to do now is we want to get a previsk. Now, I'm going to really rush it here because I want to show it. The cool thing about FTP on the mainframe is that we can use it to submit jobs. All the cool stuff that happens in the mainframe happens as jobs. And we can submit them from FTP if we're allowed to. So, incidentally, I have something created here, which is called cat TSO.jcl. Here we see what a job looks like, and we have a little job that's being running what's called a TSO command. TSO is like the mainframe shell. When we're talking about FTP, we are in the Unix subsystem, or OMVS as they call it, where we can do the Unixy stuff, and that's why I'm going from this side, because more people will be able to relate to that. So what we see here is we have this little job. And what this job is going to do is it's going to check for something called a surrogate user. And hang on, we need to ASCII, and then we have this cite command, which tells it we don't want to do files anymore. What we want to do is JES, the job entry system. So now we're in the JES job entry system. We put our TSO.jcl job in there and we run it. It gives us back a job number, job 00096. If we ls that, we see that we got some files, and now we can actually just get these like we would in any other FTP program, and it's job 00096. Dot 4 is the one that we're interested in there because that's the system print, that's our output. Okay, so it gave it to us. We go back over here, and we cat job. Nope. Did I do something silly? Probably. Thank you. I did that yesterday too. Presentation, B-sides. Okay, so cat job. There it is. That's the one we wanted. And this is the output that we'd see if we were in a TSO shell. Now, why won't it go up? Come on. There we go. And so what we see here is our surrogate user. So this means that we have submit permissions from zcall, meaning we can act as him. And it's so short. Okay. So what we saw now is we can actually run a job as zcall. The other job that I've got ready is a bash job, bash JCL. And what I'm doing here is I'm running a program called bpx batch, and this is a program that runs some bash for me. And as you see there, we're changing the permissions on our B-sides key that was in the zcall directory. Definitely going to run out of time before this is over. Yeah? Yep. I'll use that. I'll take it. Okay, so we're going to put it again. Put bash.jcl. Okay, so we ran that one. When we ls this one, when we just use the ls without any argument, we see what we've run. And then we can see the job we ran before. Why don't we see the job that we just run? We ran it as someone else. We ran it as zcall because we specified in our job card here, user zcall. And because we've got surrogate permissions, we're allowed to do that. We're allowed to be him. And so now what we can do is we can cd into his home. .ssh and see what we've got. Change the site back. and we want SEQ secret. And then we can see here, back in normal FTP land, and you see there we've actually got read on the bsides key. So let's just get bsides underscore key. Okay, and when we LL over here, we can see that we got bsides key. So we've got the private key that we need to use. Okay, 5 moments. So now we can SSH in. We just need to change a little bit of this. Bsides key, and our user is zcool. So let's see if we get in. Permissions, because of course we changed them. And then we do it again. And we are now zcool. And generally what we're doing, if we're doing that, obviously there's a reason why we've got surrogate permissions. And that is usually because we've got more privilege. So we've basically done a privilege escalation now, going from our first user, the FTP user. We were able to submit a job as zcool. We became him now. Now we've got his SSH. The last thing that we want to do is, because we've got these higher privileges, I actually want to do something, which is another TSO command, and it's rvary. Okay, and so what this is actually giving us is the location of the RACF database and the RACF database backup. RACF is the security manager that's used by most mainframes, and you have a database there that has all of the permissions, certificates, anything security related, it's all in there. Now, if we can copy that, which I'm going to try to do, we can copy it from the from this part. This notation is how you represent data sets in the mainframe world, like in the what I would call the ZOS side of things. One. Okay, we'll try and put it in here. And we'll call it RACFDB. It took a bit, so it probably worked. Okay, now we've got it. We can read that database. So what we can do now is we can go out, and I'll just SCP. Not that one. Bsides key. And then we had zcool at the Gibson. And we want to get u/zcool/RACF. I put it in the SSH. How silly of me. RACFDB. And we're going to copy it to here, RACFDB. I was out of SSH when I did it. Okay, cool. That looks better. Takes a bit to get because it's quite large. It's got all of the security information in it. Okay, now what we're going to do is we're going to use 2 minutes. Let's see if I can get it done. It's like swordfish. So now there's a tool called RACF to John. And what RACF to John does is it takes the RACF database and reads through it, and it's going to pull out passwords and hashes. And we're going to then just output them into that file, mainframe users. And then we're going to use John, word list. What's my word list? Words? I think it's passwords. Yeah. Password list. So John, word list. Woohoo. PWD-list. Typo, again, PWS. What am I doing? I'm under pressure. It's the time pressure. And it doesn't want to stop. It just doesn't want to stop. Okay, so hopefully it's not going to take too long. I've used a very special password list, of course, so that we get what we want. So it's running, it's trying to crack these hashes, and hopefully we've got some hashes. So we see there for acid burn, the password is 0cool. So we now should be able to FTP into acid burn at the Gibson 0cool, and we're in. And as I mentioned before, we had a file in there, which was the CA cert, and this is what we can use to get TSO, which get common CA cert and exit. Well, did we get it? We've got it. And now what we can do is we can use the 3270 command, and because it's encrypted and we've got the certificate, we have to use also this accept hostname because the certificate is put for a private IP, and that's why we're doing that one. We hit that one, we should be able to get in. That seemed too good to be true. Common CA cert. No certificate. Am I in the wrong place again? What did I do wrong? Oh, I know what I did wrong. So silly. Beginner mistake. Have to go back in. And we have to ASCII. ASCII. That's more like it. Get common CA cert. That's better. Okay, now see. Okay, and now we're into ZOS land. But wait, there's more. One last thing. One very last thing once it finally comes up. So now we log into TSO and we log in as acid burn with 0cool. We are in and we list our user and we see one thing. Very, 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 very special. We don't have root when we're talking about SSH, but we have special in operations. This is the highest privilege you can get. You can do anything on the system now. Thank you very much.
Give a hand.